Hello, let's do a review of finding coterminal angles and reference angles in degrees. So we know coterminal angles are any angles that have the same initial side and the same terminal side. They just might have a different amount of rotation. So for example, if I have an angle theta and I want to find an angle that is coterminal, I can add 360 degrees to it. And if I want to find another angle, then I could add another 360 degrees to that, and so on and so on. Or I could subtract 360 degrees, get an angle, find another one, I could subtract another 360 degrees, and so on. So basically, we're adding and subtracting multiples of 360 degrees. And we said we can take care of this adding and subtracting by using an integer to represent the number of times we add 360, the number of times we subtract. So an expression that will generate all angles in degrees that are coterminal with the given angle would be take the angle and add 360 times n. So we're going to let n be the number of times we add. And we're going to say that n is an integer, which means it represents a positive and negative whole number. So when it's a positive integer, we're adding. When it's a negative integer, we are subtracting. Okay, so let's do a couple examples here. So I want to know in what quadrant the angle lies so that I can find its reference angle and I can then find its trig function value. So if I have an angle of 585, I know it's more than one full rotation. So I like to take off any full rotation so I can get down to what I call the least positive coterminal angle. So if I subtract here, I get 225 degrees, which is between 0 and 360. So we use the little notation there, theta sub c, meaning the least positive coterminal angle. And we talked about our 8-sector circle. If you recall, we divided the circle into 8 equal parts. Each sector is 45 degrees. So 225 degrees is going to be located in quadrant 3, because I know this is 180 plus 45 gives me 225 degrees. So the terminal side of this angle of 585 degrees would terminate in quadrant 3. Okay, now that means any angle coterminal with 585 terminates in, has that same terminal side. So I'm not going to show the full rotation. What I care about is what quadrant does it lie in and what is its reference angle. Well, we know that each sector is 45 degrees, and if you recall, the reference angle is the distance from the terminal side of the angle to the positive x-axis. So this distance from 225 to 180 degrees is 45. So I went past 180 degrees by 45 degrees. And reference angles always have positive measures because it's not a rotation, it's just that distance between the two. All right, so how about an angle of negative 600 degrees? So I'm going to add some full rotations to get to a positive number. And I believe I'm going to have to add 2 full rotations. So I'm going to add 360 twice, or 720, which is going to get me to an angle of 120 degrees, which would be the angle of least positive measure. Okay, there are lots of other angles coterminal, but I'm typically looking for that one. It seems to be the most user-friendly. So 120 degrees. So this is our 12-sector circle. Each sector is 30 degrees. So that means then we can go by our 60 degrees or 30 degrees, but typically we think of it as a 60 degree. So if I count 2 sectors as 60 degrees, then I'm at 60, 120. So I'm going to terminate in quadrant 2. Okay. And then I can find the reference angle, which remember is the distance from the terminal side to the x-axis. So I need to know this distance. That's my reference angle. Okay, so if this angle we said is 120 degrees, then remember if we went clear to here, 180 degrees. So to find my reference angle, then I'm going to take 180 minus 120, and I get 60 degrees. Okay, and there you go. Nice review of angles and degrees.